Grigor Dimitrov has staked his claim for the title of best tennis shot ever with this effort at the Swiss indoors.
Between the legs, but he took it around the back. How did he do that?
But he's got some hot competition coming from some of the game's greats. What about a lob from between the legs by Rafael Nadal against Novak Djokovic?
Novak was kept on the net here. But not Nadal.
And Andy Murray could argue his running forehand around the net was even better. But for sheer athleticism, it's hard to go past Andy Roddick's diving passing shot against Canadian Milos Raonic. Or do you think Roger Federer should win for this between-the-legs masterclass for Novak Djokovic?
Alright guys, I wasn't sure if I had any tennis fans or not in here, so I just figured I would share that with you. Again, we're talking about quadratics, and the whole idea is still there. Okay, the parabolas, all of that is still there. So let's take a look today at our next set of notes. Okay, we're taking a look at factoring, 5.2b, graphing quadratic functions. Should be called factoring part B. So our daily questions, taking a look here, we can multiply the 4 in. This is the same thing as yesterday. We're expanding upon it now. It's a trinomial instead of a binomial. So 8x squared plus 20x minus 48. Just make sure you are multiplying all the way across. Okay? Simple enough. I think we're okay. I'm not too concerned about that. Solve the following by factoring. Okay, now, because my leading coefficient is 1, alright, I can go ahead and set this up. Signs go with, negative 21 goes on top, 4 goes down low. Two numbers that multiply give me negative 21, but add to 4. Positive 7, negative 3. Okay, so now when I set this up, x plus 7, x minus 3. Notice how it says solve by factoring? Okay, this is very similar to what we did yesterday when we talked about the x-intercepts and solutions. You can now set each of these equal to 0, and we can solve for it. X equals negative 7, x equals positive 3. So when it says solve, we don't have to put it in point form. Okay, we can leave it as such. X equals negative 7, x equals positive 3. Alright, so just be aware if they're asking for the solutions or the x-intercepts. If you did put that in point form, I would totally be okay with that. But anytime it says just solve for x, that's what you're looking at right there, because that is the x value that makes y equal to 0. Alright, greatest common factor. The largest value that can evenly go into all terms. In your particular function. Okay. Now you can have a greatest common factor that's a number. You can have a greatest common factor that's a variable. Okay. So I mean, you can look for the number or the variable that goes into all of the terms in your particular function or your equation. All right. We are always, 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 always. How many more times can I say always? Let's figure it out. Always, always. Is this annoying yet? Hoping it is. Always, always, always. Okay, I promise I'll stop you soon. Always, always. Going to look for this first. You always want to look for GCF. This is your easy ticket. Alright? If you have a GCF, your life is good. Did I mention you always want to look for this? Just curious, because you always do. Ha 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 ha. Please don't hate me. Okay, now. Number 1, sketch the following by labeling 0 as vertex AOS, check for GCF. We're going to factor this, and then I'm going to show you a graph again to show you how it works over here. 6x squared minus 4x minus 10. If you didn't look for a GCF, because you should always look for it, I know, right? You're going to get really annoying fast. Before you do anything, factor out your GCF. What number goes into all 3 of these terms? 2. So I'm left with 3x squared minus 2x minus 5. I just divide all 3 of these by 2. Now, I'm going to let that 2 chill out front. But the rest of this now I'm going to factor like I normally do. 3 times negative 5 is negative 15. That goes up top. Negative 2 goes down low. What two numbers multiply to give me negative 15 but add to negative 2? Negative 5 and 3. So when I set this up, I know I have to have 3x and x. Remember your smileys. Can 3 go into negative 5 or can 3 go into 3? Hopefully we're all okay with 3 going into 3 and the other one's negative 5. What times 3 gives me 3? 1. Go to the other end and put 1. What times 1, there's a 1 in front of this x, gives me negative 5. Negative 5. So I'm going to write this one more time for everybody so we're all good. Okay? Awesome. Now, if I want to find my zeros, this is the same exact thing as yesterday. It's nothing new, ladies and gentlemen. Down here I'm going to show you guys 3x minus 5 equals 0, x plus 1 equals 0. Add the 5 over. Divide by 3. Okay, subtract 1, subtract 1. These are my zeros. 5/3, comma 0, and negative 1, comma 0. So what that looks like is 5/3 is roughly 1.66. Alright, so right about here. And negative 1, comma 0. Very good. Alright, now if you want to find your vertex, just to show you super quick, we can do 5/3 plus negative 1. Divide that by 2. So 1/3 is my vertex. If I plug 1/3 back into my original function, 6 1/3 squared minus 4 times 1/3 minus 10. Negative 32 over 3, or negative 10.66. Okay, so it would be roughly down, let's see, way down here. Okay, so your graph would look completely just kind of drawing a rough sketch here, like so. Okay. The important part out of this is that I want you guys to make sure you're comfortable with the factoring and the zeros. Okay? And your AOS would be, just in case you guys forgot, would be your 1/3. Cool? Awesome. Alright, on to the back. Hey, did I mention to you guys about always looking for GCF? Just curious, I didn't know if I forgot that. Alright, just want to make sure I didn't forget that. Alright, number 2, looking for your GCF, because we always want to look for that, right? Alright, so 4, negative 24, and 32. What number goes in all of them? If you're saying 2, good idea. Make your life even easier. Try 4. Y equals 4, x squared minus 6x plus 8. Okay. Now let the 4 chill out front. 8 goes up top, negative 6 down low. We're looking at negative 4 and negative 2. Ooh, this is a nice one, because our leading coefficient's 1. So I got just x minus 4, x minus 2. Okay. This is fully factored. I'm totally good now. Okay, that's what I'm looking for. Now, if I asked you for your zeros or your x-intercepts or your solutions or whatever you want to call it, because they're all interchangeable, we could say 4, 0, 2, 0. If anyone's panicking like, why is it 4 and not negative 4? All you're always doing is just taking each of those parentheses, setting equal to 0, and solving. Okay? That's where it's coming from. So over here, 4, 0, and 2, 0 look like that. If I want my vertex, it's just in between 4 and 2. So it's 4 plus 2 divided by 2. Which gives me 3. You can plug 3 back into my equation up top. Just to show you guys real quick. 4 times 3 squared minus 24 times 3 plus 32, negative 4. So there's my vertex, 3, negative 4. Okay, roughly like so. If you wanted your AOS, x equals 3. Alright? But again, the whole point of factoring, if we're trying to graph, is you can put an intercept form, but it makes it so easy to solve. It's such a nice thing. Okay? And what do we always do? We always look for GCF. I know. Just curious. I don't know if you heard that before. I love running jokes if you guys couldn't tell, by the way. All right, so very last one then. Okay, down here in numero trace. All right, before we start this problem, what should we always do? Haha, you're probably giving me nasty looks right now in class, I know. You are always looking for GCF. All right, so for g of x. And by the way, don't panic too. Just a quick little side note. See, I have y equals up here, and I have g of x right here, and I believe in the front one it was f of x. These are all the same thing. They all basically stand for y equals, so just be aware of that. Factor out of g, or yeah, factor out of g. Factor out of 5. Good. Okay. Now, I'm going to factor this. We got negative 5 up top, 6 down low. Okay. This is the problem. I need to make sure I tell you guys something. I wanted you all to change this negative 25 to positive 25. Remind me in class. Okay. So this would change to a positive 5. That means you need 5 and 1. So x plus 5, x plus 1. There's my fully factored term. So if I want my zeros, or my x-intercepts, it would be the opposite, negative 5, 0, negative 1, 0. Again, how am I getting that? Set each of these equal to 0. Okay. So negative 5, 0 is back here. Negative 1, 0 is like so. Negative 5 plus negative 1 divided by 2 is negative 6 divided by 2 is negative 3. That means your vertex is negative 3, comma. Take your negative 3, plug it back into your original one. Looking at 5 times negative 3 squared plus 30 times negative 3 plus 25, negative 20. Okay. My AOS, still just negative 3. I'm not gonna, it's down here. So I mean, I'm gonna just make this drop. I know it's not drawn to scale, so please don't, panic. It would look something like that. All right. So the only thing new for today that we have is basically you're looking for a GCF. And when we want to do this, the word is always. Okay. We always want to look for a GCF. After that, it's the same routine. Now, once you guys are finished with this, take a look at your homework. You need practice with this. All right. Even if you are very good at factoring, a little bit of extra practice is not going to hurt you. All right. You want to ingrain this in you. Factoring has so many applications later on in your mathematical career that if you have it under your belt and you're comfortable and confident with it, you can do a whole lot of things. Okay. This is an excellent opportunity for you guys to really rock out in this and do well. So if you have any questions, feel free to ask. If you would need additional practice with factoring, I have tons of resources for you. All you have to do is ask. If this video was helping, great. If not, feel free to ask in class. I'll gladly help you as well. And most importantly, okay, good luck. We're all counting on you.